Hello to all my nines out there. So I thought today I would try my first attempt at an online video to perhaps help you guys as we start to go through some new material in our course. A couple of you reached out saying that you were sort of having some troubles and weren't really sure what to do. So I thought this might be the best, one of the best solutions because it'll kind of try and mimic, or I'll try and mimic, sort of how I would explain it if we were in the classroom. Which, side note, I miss you guys, and I hope that we get to see each other in person again real soon. So we're looking at scale diagrams. So a couple things when you're talking about scale, we're looking at a comparison between the actual size of something and then the size of a diagram that you might have on a piece of paper in front of you. Couple ways you can express this. So it tells you you could have a ratio. So a ratio would look like maybe 1 to 2. You could also state it as a fraction. We've done lots of fraction work. That would be like 1/2. You could also use a percent. So it might tell you that it's been scaled up or down by a certain percentage. So this would be like 50%. And then as usual, you could use words or also just literally have the diagram in front of you. Okay, now I'm going to focus in on this little formula. So if you're trying to find the scale, okay, normally we're going to focus in on the diagram measurement. So that would be like the measurement you actually see on the page in front of you. And then comparing that to the actual measurement. So in real life, what would the actual measurement be? Okay, and then a couple things about scale drawings. Key takeaway is a scale drawing is going to be either smaller or larger than the actual, but really important, it has to have the same proportions. So if I look at this scooter picture, if you imagine if I were to zoom in, make the scooter bigger, or zoom out, make it smaller, I've maintained all the proportions. Okay, so it has the same proportions whether it's zoomed in or zoomed out. So example 1 tells you the scale diagram of a scooter is 1 to 20. What is the actual length of the scooter? So as you guys know, I would go back, find some information. Okay, so it tells me 1 to 20 there. Figure out what the question wants me to find. So it wants the actual length. And then I might highlight the fact that I do have some info in the picture. So the picture is telling me that this length, so from like the front to the back of the scooter, is being represented as 3.5 centimeters. Okay, so let's go back to the info we're given. This 1 to 20, okay, what that's telling you is basically it's saying like 1 centimeter in the diagram, so the picture that we have in front of us, is technically representing 20 centimeters of the actual, so if you had the real life scooter in front of you. Not that a scooter really is like real life, but you get what I mean. Okay, so we want to find the actual length. Well, I'm going to go back up here. We had this little formula. So scale is going to be diagram measurement over actual. So one way I find it easier to deal with scale factor questions and scale drawings is to set up a proportion statement, okay, because we're used to setting those up. So I'm going to point out that the diagram measurements will always go on top, and I'm going to compare that to the actual. Okay, now this is where I'm going to change the way I explain this. So if you've already looked at my notes that I posted on my website, I'm going to switch it up a bit. So I think it makes sense that if we always talk about the scale on the left-hand side, I'll put a little label here. So in this question, it says the scale is 1 to 20. Well, this I could rewrite as a fraction, like 1 centimeter is representing 20 centimeters. Okay, so that's going to be a bit different than the original notes that I posted. I realized I think it might make it a little bit clearer for everyone. Okay, so scale is my factor. So 1 centimeter is representing 20 centimeters. And then if it's a proportion statement, I have to have another side to this. Got to fill in a number on top and a number on bottom. Well, here's the issue. The only other number I know is this 3.5 centimeters. So then I decide, well, does it go on top? Is it a diagram measurement or is it the actual? Okay, well, if it's 3.5 centimeters, most likely that's not going to be actual because if it's supposed to be like a real scooter, not many humans would be able to fit in it, if any. So 3.5 is your diagram. So it's going to go on top. And then if I want the actual length, okay, you could technically pick any letter you want. By default, most of the time, we just use the variable x. Okay, so this is what we're trying to solve for. Okay, now if you just ignore the question for a second, so if I zoom in here, if I were to give you that, okay, imagine this picture is not here, and said solve it, well, I know that I have a fraction on one side, a fraction on the other side. Okay, so really I have a proportion statement here. I can solve this by cross multiplying. So I'm going to multiply top times bottom. So I'm going to go 1 centimeter times x is really going to give me x on the left-hand side. I'm not going to write the 1 here. You don't need to. And then I'm going to have 20 times 3.5 on the right-hand side. Okay, I'm going to clean this up. You would get that x is equal to 70. Now, you'll notice that technically I dropped the units. I'm going to check these are the same. So actually they would cancel each other out. So then I often do my work, I come back to the final answer and then realize, well, this must be representing centimeters. Okay, so I found that the actual length would be 70 centimeters. Good habit, right? It is a word problem. So you should say the scooter's actual length or length of the scooter, doesn't matter, would be 70 centimeters. Okay, and that would be the final answer for example 1. So again, if you were looking at my notes that I originally posted, solution was a little bit different. I had these two actually switched around, but I think it makes more sense. Start with the scale always on the left-hand side. Okay, number 2. So this time we have an actual laptop, has a width of 39.5 centimeters. Question says calculate the scale factor used in the image and express the answer to the nearest tenth. So you go back, find your info. So the actual, keep my colors the same, actual was 39.5 centimeters. You're trying to find the scale factor, and then this will be important. So it does want to the nearest tenth. So reminder, that would be like 1 decimal place. Okay, now you also have some information in your picture. Okay, so the picture shows that it is 4.2 centimeters. Okay, well, that would be a really teeny tiny computer. So clearly this would be representing diagram length. Okay, and then it wants us to find the scale factor. So reminder, what it's really wanting us to figure out is this, okay, because that formula represents scale factor. So again, I would start it the same way. I know I would have a diagram measurement on top, an actual measurement on the bottom. Okay, I'm trying to figure out the scale. So I will put the scale on the left-hand side. I'm going to set up my proportion statement. Okay, so this time I want the scale factor. So I want to figure out what does 1 centimeter in the picture, right? Because the picture has it in centimeters. So if this was like meters, this would have to match and be meters. So the question is saying, what does 1 centimeter in this picture represent of the actual? So I don't know that, so I'm going to put that as my x. Okay, well then I got to fill in these values, right? So if I already have my unknown here, I need to know this value and that value, otherwise we're going to get stuck. So if I read the first sentence, actual laptop has a width of 39.5 centimeters. I'm going to figure out, does that go on the top or the bottom? Well, if it's actual, actual goes on the bottom according to my setup. So this is 39.5 centimeters. And then I still need another number, the diagram. Well, if I look, diagram told me it's 4.2. So I put the 4.2 on top. Okay, so again, if you ignore the question for a second, and if I said try and figure out the value of x, okay, I know that I can cross multiply. So I can go top times bottom, top times bottom. So I'll go 1 times 39.5 is just 39.5. Oops, sorry about that, pen skipped. So 39.5. Again, I like to drop my units when I'm doing my work. I can do that because these are matching. Okay, so I'll drop the centimeters. Other side, I will go x times 4.2. Well, that's going to be like having 4.2x. Okay, keep in mind, it's like there's a multiplication symbol here or a dot, but you don't have to write it. Okay, now, a bit different than example 1, I have to do one more step. So I need to get the x by itself. So to undo this multiplication, remember, I could then divide this side by 4.2. Those will cancel. But then whatever you do to one side, you have to balance on the other side. So I'll divide that side by 4.2. And then you would get that the left-hand side will come out 2. And if it's rounded to one decimal place, it should be 9.4. So I get 9.4 is equal to x. So we are saying that x is equal to 9.4 centimeters. Now, the common error on a question like this is students will think that 9.4 is actually the answer. So they'll try and say that that's the scale factor. But if you look back at the way we set this up, we actually said that this was our scale. So 1 centimeter is representing some amount of centimeters in our actual. So if I fill that in, so our scale here, we already said that 1 centimeter was representing, now instead of x, I can say 9.4 centimeters. And again, when you're stating scale factor, you actually don't include units. So we would say the scale is 1 over 9.4. Okay, or you could say the scale is 1 to 9.4. So this would be ratio format. Let's write that down. So this is ratio. This is fraction format. And then another option, you could use words. So you could also say 1 centimeter represents 9.4 centimeters. Okay, keeping in mind that this is your diagram, and then this number is the actual. And what I'm noticing, there's some questions that are coming up. In terms of what sort of the textbook does for their solution, is they're taking the fraction and then changing it to a decimal. So because this also kind of looks weird to have a fraction with a decimal in it. So if you went 1 divided by 9.4, keeping in mind it wanted to one decimal place, you could also say the scale factor is 0.1. And I'm going to remind you, looping back to section 4.1, if you have a scale factor that's less than 1, okay, so this means object, which in this case is the computer, has been reduced. Okay, so section 4.1 talks about enlargements and reductions. So this has actually been reduced because the scale factor is less than 1. If it was bigger than 1, we would call it an enlargement.